Hey everyone, we're going to wait a few minutes for everyone to be able to join on time. But we're looking forward to this today.
And feel free to drop any questions or comments during the presentation in chat. We'll make sure to answer them at the end as well.
Yeah, for sure. I mean, we're curious about all the questions that you have, and if you have any issues with CodeQL or anything like that, we'd be happy to answer them. Okay, I think we're ready to start. Welcome everyone. This is the second episode of our webinar, and today we're going to talk about CodeQL and how we use CodeQL at Trilobit. My name is Fredrik Dahlgren. With me, I have my co-hosts Vasco and Filipe, who will be helping out today. Hey guys. And as Filipe mentioned, if you have any questions at any time, please drop them in the chat or in the Q&A section, and we'll try to get to them as we go along. But the starting point for this webinar was basically that we often use CodeQL on code review engagement. So we all work at Trilobit in the assurance practice, which basically means that we do code reviews for high assurance code bases. This is one of the things that we do at Trilobit. We're a security company, as you probably know. We do, apart from code review, we do security research and we do engineering in the security space. But what we found in our code review projects was that even though we find CodeQL to be super useful when we do variant analysis, we found that our clients weren't really using CodeQL in CI, and they weren't really using CodeQL to do variant analysis if they found bugs in their own code bases. So we really wanted to help people out and sort of show how we use the tool and what we like about it, basically. So we are going to look at that today. But before we start, I just want to take a second to plug our testing handbook, because all of the content that we'll go through today can be found in the testing handbook. It's basically sort of a one-stop place where you can find information about how to use static and dynamic analysis tools, or how we use static and dynamic analysis tools like CodeQL and Semgrep. It also contains information on fuzzing, and we also take some time to discuss which tool is appropriate for the job. So sometimes it makes sense to use Semgrep to model an issue. Sometimes you get more bang for the buck if you use CodeQL. So there's content like that in there as well. So please check that out. And if you have any comments or if you find any issues, then just leave an issue in the GitHub repo. And we also take requests, I want to say. Okay, so let's get started with CodeQL. I think most of you probably know, since you're already here, you know something about CodeQL, right? CodeQL is a code analysis engine. And to use CodeQL, you need to build a CodeQL database. So you can think of this as a huge SQL database that you can query about your code. So this database contains all the semantic information about your code base, and you can then use that to query to run queries on your code base and find security issues. CodeQL supports most modern languages, and for each supported language, you get a huge standard library that you use to write custom queries. And there's also a large number of precompiled queries that are included with the tool. And I think that is super nice, because these can be integrated into CI/CD without any knowledge about CodeQL whatsoever. So you can sort of get the benefits out of CodeQL without even knowing anything about how the tool works or how to write queries. Okay, great. So now that we know what CodeQL is and what you can do with it, let's dig into a few examples of how we use it at TrailBits. And this first example is from the world of cryptography. Actually, the second example will be as well, because both me and Filipe are cryptographers. So this was from a very recent project where I was reviewing a code base that implemented a number of cryptographic protocols in constant time. So that basically means that if an attacker who has precise timing information about your application, an attacker like that shouldn't be able to learn anything about the secret state of the application. So you can sort of think of this as sort of the canonical example is that you have an application running in SGX on a compromised host. So the host may try to obtain information about secret keys or other secret data through timing measurements, and that's actually been shown to be possible. Even though, I mean, this attacker model is very, very strong, right? But since we can mitigate against it by writing code in constant time, which basically means that we don't leak any secret values through timing measurements. Since we can do that, we probably should, right? So one thing that you shouldn't do if you want to write constant time code is that you don't want to use secret values to index into arrays or more generally to address memory. Because as you probably know, on modern computers, you have RAM, but then you have a cache system, which caches frequently used memory. So that means that you can infer information about the address from whether or not you got a cache miss or a cache hit. And obviously, if the data you want is in the cache, that you can get that a lot quicker than if you need to go back down to RAM and access it, right? So that gives you a timing side channel that you can detect as an attacker. So you don't want that. So here we have a part of a function where the implementation gets this a single bit using this function constant time select, and then it uses that bit to index into this array called hash keys. And since this bit is actually a secret value, it's actually the sort of secret for this participant of the protocol. This is not very good, right? So we want to avoid that. So we flagged this to the client, and they were super happy about that. But we were sort of curious if they did this somewhere else in the code base. And this is a place where CodeQL really shines, because if you think about this for a bit, how you would model this, it's actually a data flow query or a sort of taint tracking query, where we want to look at outputs from this function constant time select, and we want to make sure that they don't flow into an array index operation. And this is something that CodeQL is really good for. So let's look at how we model that. So obviously, to start, we want to define what it means to be a random choice bit that shouldn't end up in an array indexing operation. So to define this, we define something called a select call in CodeQL. And this is a special case of a method call, right? So we see this is the top class that we define here. And this basically, if you haven't seen CodeQL before, this kind of looks like Java, right? And basically we extend this class called a method call node, which is used to model a method call. And the callee name should be constant time select. That is the method we're interested in. And then we can, maybe it makes sense to restrict the receiver as well of this call. So that is the object we're calling it on. So here it might make sense to call it choice or something like that. So that's what we did here. And then a random choice bit is basically a call to this method, right? A select call, or rather, it's the output of the select call. Great. So now we know what a random choice bit is, and that will be the source of our data flow. So now let's look at what that would look like. So to do a data flow query in CodeQL, you define a data flow configuration. And that is basically just a class which defines what it means to be a source and a sink for the data flow. So the source is I mean, that it's, I don't know, maybe the names are obvious, but the source is where the data flows from. The sink is where the data flows to. So here, the source should be a random choice bit, and the sink should be an array index. And we didn't look at what it means to be an array index, but it's kind of obvious, or no, I don't want to say it's obvious. It is possible to define using CodeQL, right? So, but we didn't look at that. Okay, so now we know what our data flow looks like, and we'll just, at the bottom here is sort of our standard CodeQL query where we sort of say what we're looking for. It's basically a SQL query on its head, right? So we have this from statement saying what kind of types we're interested in, and then we have a where statement sort of restricting those. And the where statement here basically says that there should be a taint flow from the secret value to the array index. And taint here, I mean, there's a slight difference between data flow and taint flow or taint tracking in CodeQL. So with data flow, we track the actual value as it moves through the application. But with taint tracking, that is a bit more general, right? So with taint tracking, you could have a value, and then maybe you add 5 to it, and then maybe you pass it through some other function, and that taint propagates. So that sort of, you can think of it as paint, right? I walk by someone who has paint on them, and I get paint on my shed, and then so on, and suddenly everyone has paint on them. So it's a bit more general, which is what we're interested here. And then finally, we select the locations of this array index operation. And this actually found us, I think, 4 more locations where they had this pattern, where they were using secret data to index into arrays. So that was I think that was a great success. It made the client very happy. It allowed us to sort of find all the places where they were vulnerable, and they could sort of go out and fix it. So obviously, you could say here that, I mean, Fredrik, you could have just, I mean, knowing this, having found this vulnerability, right, you could have just sort of popped into the other implementations of the same protocol and checked for this. And yes, that is true. But I think what's nice about this is that at the end of the project, we could give them this query. They could run it in CI, and they could make sure, right, that they would never be vulnerable to this again. I mean, because now suddenly this query is running in CI on each pull request, so they would find if they for some reason reintroduce this vulnerability, they would detect that immediately. So I think that's really nice. And more generally, this is something that we often recommend, that you write security, you write rather CodeQL queries for your security invariants for your code base, and then those sort of serve as a form of regression testing for your code base. So you make sure that you don't introduce the issues that you've had again in your code base, because they'll be found immediately using CodeQL. So I think that's really nice. Something else I want to say here, if we go back to this previous slide, this is something that I often do, that I try to break the query down into sort of smaller steps. So we could have defined all of this in one big query, right? But obviously that would have been a lot more difficult to read. But also, if we break it down like this, we can actually test each component separately. So you can test this select call and make sure that it actually finds what you expect it to. And I mean, I don't know what your experience is, but my experience is that I usually make some mistake, and then I don't get any hits or I get millions of hits, and I can fix that sort of by this iterative process. So I can make sure that each component actually models what I want to before I move on. So I think that is pretty nice. Okay, so let's look at our second example here.
Yeah, and with the second example, I'm going to tell a story of a very different client. This client had a C code base, and although they had secret data lying around, they weren't particularly concerned about constant time computation like the previous client. But in C, if you have secret data lying around in memory, it's often best practice to clear this data from memory when you no longer need it.
So Filipe, would that be like a defense in depth for a problem like Heartbleed, where you can leak memory from an application?
Exactly.
Is that right?
So,
yeah.
So if you leave secret data in memory, if there's any vulnerability, let's say that can leak data from the server running this application, then if you clear the memory, you'll read a bunch of zeros, while if you don't clear the memory, you'll actually get the private key, and this would be very bad for your application. So the scenario here is we have this application that handles secret data, and in the snippet that you see here, it handles a signing key. And in this signing function, they do some serialization of a message, and then at the end, they sign the message using the key. And finally, before returning, they'll erase the key from memory. And this is all good. We want to make sure that the key is erased from memory, and if we look at it from how it is before we return 1, we actually are erasing the memory. But is this always the case? If we look a bit more into the code, we'll see that there are actually 2 paths that the function exits, but the signing key is not erased from memory. In the first path, perhaps the key is not actually in memory because the get signing key did not return okay. So maybe this is fine. But in the second case, when the message serialization failed, for sure the key will be in memory because it's going to be used straight after this. So by returning early and not erasing memory, we're going to leave the key in memory for whoever knows how long time. And this is obviously not what we want. And we want to make sure that all paths that go from the get signing key function into a return statement will pass through erase memory. We can do this manually, as we just did now, and as I did when I was doing the engagement. But I wanted to make sure that for sure there were no other paths besides this one that I found here with a serialize failure that didn't clear memory. So I set up to do a CodeQL query to do this. And the way to do this is basically the same as you do it manually. You start by finding all function calls to get signing key, and then finding all paths from that function call into a return statement for this function. And to my surprise, I had missed a couple of these places where, besides the one I had found, there were 2 other places where the memory was not being erased for the signing private key. And this might seem surprising if you look at the function like this, how it is, but the code base was actually much larger. The function was huge. They had very complex control flow with goto statements and macro expansions. So it's not surprising that someone like the developers or a manual auditor would fail to miss one of these paths. And using CodeQL, I was able to find this, and the client was extremely happy. But that wasn't the end of the story, because the week after, I continued in the review, and suddenly I realized there was another place where memory wasn't being erased. And I thought to myself, so what happened here? Why didn't the CodeQL query find this? Well, as the saying goes, if what you're looking for are signing keys, what you're going to find are signing keys. And in the particular example, the data that wasn't being erased wasn't a signing key, was some other type of key or some other secret data. So by forcing the query to find signing keys and then try to find a path where they weren't erased, I was missing all other places where memory was being erased, but not on all paths. So the query had to be changed a bit, and instead, the way to do it would be to first find all places where memory is being erased and what are their arguments. And from there, I can find where these arguments are assigned first. And then going forward again, how can I find a way going from their assignment to these arguments to then a return statement for this function where I don't erase the memory for these. And this query allowed me to find the previous results that I had found with the query before, and also manually the new results, but also some extra new results. And obviously, we were all very happy with the result from this, and we were sure that now we had all places fixed. There were no complex code paths that we missed somehow, and also the client could deploy this rule into CI and make sure that, let's say, a new developer comes in and he makes some change to the function. He does not realize that memory needs to be erased for this particular value. And then this is immediately caught by the CI rule, the CodeQL query that's in CI running. Another thing to mention here is that both these examples, as Fredrik said, are related to cryptography, but you can always model vulnerabilities or other types of security invariants in your code base using CodeQL. And the reasoning we used here can very well translate to other types of security invariants. Like we've used this to find double free or other memory corruption vulnerabilities before. Were you going to say something, Fredrik?
No, I just wanted to agree. I mean, these are the data flow engine in CodeQL is really general. So obviously we use it for cryptography here, but we also use it to model other types of vulnerabilities. Thanks, Filipe. So we've mentioned now when we've sort of looked at a few examples, I think it makes sense to take a step back and compare CodeQL to Semgrep, right? Because that is another static analysis tool that we use a lot during code reviews. And there are a number of similarities and a number of differences. So I would say personally, I typically start out trying to model a vulnerability using Semgrep, right? Because it's a lot quicker to get off the ground using Semgrep. You don't need to build a database. You don't need to set up a query pack. You don't need to be able to build anything. You can just sort of write the query and run it straight away. So the feedback loop is really quick. I don't know, how's your experience, Filipe?
Yeah, I agree. Especially not needing to build the CodeQL database makes it so it's just much easier to start writing and finding something. One place where I would never use CodeQL because it's not possible to use CodeQL, and this is in Rust code bases. Unfortunately, CodeQL is not available in Rust, but we do a lot of security engagements in Rust nowadays. So this is very unfortunate for us.
Yeah, that's a really good point. So I'd say a lot of the code bases we see, especially for cryptography, since they're high assurance projects, right? They use Rust. Sometimes they use Go, but very often they use Rust. And obviously we can't use CodeQL for that. So that is sort of one thing that you have to keep in mind. Obviously, if the language isn't supported, then you can't use CodeQL. I think a strong point of CodeQL is the amount of semantic information that you do have available. So sometimes you find in Semgrep that you just can't model what you're trying to find correctly, right? Or you're just getting loads of false positives and you can't figure out how to exclude them. And then I think it usually makes sense to start looking at CodeQL and see if you can move over and then sort of use that semantic information to narrow down your query. I think the two examples we've seen here, right, are data flow with tame tracking queries. And I think that is the place where CodeQL really shines. And Semgrep usually falls down pretty quickly. So I know they do have some support for data flow and taint tracking, at least within a single function. I actually tried to use that today, and it just found crazy stuff, right? It just didn't work at all. So if you want to do something like that, I think it definitely makes sense to use CodeQL. On the other hand, I think a strong point for Semgrep is that the syntax is basically the same for each language you're looking at. I mean, obviously, the actual pattern that you write is in the target language. So of course that will differ somewhat. But I mean, if you understand the target language that you're looking at, which you probably do, because either you're a developer or a security researcher, right? Then you won't have any problems writing queries for that language. Whereas for CodeQL, the standard library is really different for different target languages. So as an example, if you want to model a function call in C++, the type that you use is called function call, which makes complete sense, right? If you want to model a function call in Go, the class is called callExpr. And there are a bunch of differences like that, which means that you basically have to relearn the entire standard library when you switch target language, which is a big pain, right? And what I find in practice is that a lot of people just sort of stay on one language. I mean, if they work mainly with Go, they learn CodeQL for Go and they don't learn it for any other language, which I think is a shame. The final difference, which I think stops some people in their tracks, is that CodeQL may require a license. If your repo is public and open source, then you're free to run CodeQL on it, and you can run CodeQL in CI as well. But if you have a private repo, then you need GitHub Advanced Security. So I think that is a good thing to consider as well.
Another different aspect between CodeQL and Semgrep is regarding the available and public query sets. And in this regard, CodeQL has a much larger and more diverse set of rules, and also supporting a lot of frameworks in the standard library queries. So if you just run the standard pack CodeQL rules for C++, let's say, this will generally find more issues or cover more issues than the standard C++ Semgrep rules. And this is also another aspect. If you're just going to run rules in CI and not write rules, consider using perhaps both, but CodeQL probably will have more coverage in terms of what it finds.
Yeah, that is definitely a good point. Okay, so I hope this section has got you at least a bit excited about what CodeQL can do and what kind of issues you can find. We think that it's an amazing tool, even though it can be a pain sometimes. And we think that you should probably be using CodeQL if your language is supported and you're covered by the license. So that basically means that if your code base is public and you have an open source license, or if you have GitHub Advanced Security, it definitely makes sense to use it in CI, but probably also to use it to write custom queries if you have the ability. Okay, maybe it makes sense to check in with some questions before we move on. I noticed we had a question regarding your example, Filipe, on the erase memory function.
Oh yeah, so someone asked, is erase memory a function that cannot be eliminated by the compiler? That's actually a great question. So in C, when we handle this type of, when we want to erase memory or clear memory and data from memory, often people will write specific functions with some compiler annotations that prevent it from being eliminated by the compiler. And obviously, this would need to be checked after the build is done. But there are tricks and ways to make sure that this is prevented so that the compiler will not eliminate that call. But that's actually a good point, because sometimes people think they are eliminating memory or clearing memory, when in fact the compiler is then just removing that call and the memory still lies around. So that, yeah, that's a great concern you should have. And the way to fix this would be to look into the build after it's compiled. Yeah.
Yeah, that's a good point. Okay, let's look into some of the tooling that we use when we use CodeQL. So obviously, we need to use the CodeQL CLI, right? That's the sort of base CodeQL tool that you use to build databases, to run queries and run query packs, and also to do some low-level plumbing if you need to do some troubleshooting. But then, even though you can triage your results on the command line, that usually doesn't make sense if you have a large code base and a lot of results. And it's also nice to have a good, like, GUI application where you can write your queries and debug them, right? So we usually use VSCode, and there's a great VSCode extension for CodeQL, which provides code completion and syntax highlighting. You can run and debug queries using this tool. There's also a similar one for NeoVim, which I've used before, and I think it used to be great, at least. I think it's probably great still. It also provides code completion and syntax highlighting, and you can run queries from inside of NeoVim and sort of look at results. So I think that is really great if you're using that. We also have our own custom tool to triage results, which is called the SARIF Explorer. And we'll talk a bit about that later, but basically that allows us to classify results as bugs or false positives. It allows us to filter results if we have a huge number of results for a code base. And we can also export them directly as GitHub issues, which can be useful. So let's look a bit at each of these. And in our Semgrep webinar, if you went to that, we had a Semgrep in 30 seconds. I think for CodeQL, I mean, everything with CodeQL takes a bit more time, right? So I don't think 30 seconds makes sense, but maybe you could do this, like get started, download the tool and run it in 60 seconds if you're quick. So to download CodeQL, you go to this URL and download your release for your platform. You can also install it using Brew. But what's nice about this is that you get all the sort of pre-built queries together with the tool. So the correct version, pre-compiled. So that is super nice. You should use that since it's there. Then to build a CodeQL database, you use the subcommand CodeQL database create. And you have to give the name of the database, you have to provide the language, and sometimes you even have to provide the build command, right? If it's a compiled language. Sometimes CodeQL can actually figure that out, but sometimes you have to provide it. Then to run queries, you use the command CodeQL database analyze. And there you specify the output file, the output format, and the sort of query pack or query suite that you want to run. And CodeQL supports outputting to CSV, but we usually use SARIF, which is a static analysis output format, which is pretty good because it has good support, like good tooling support. In particular, we have this SARIF Explorer, which allows us to run a bunch of tools that output SARIF, the static analysis results, and then just dump those into VS Code. I look at all of them in the same place, which is super nice. So that is what we usually use to triage results, and Filipe will show that in a bit.
The official CodeQL VSCode extension is something if you use VS Code in your daily life, let's say, and you want to write custom queries, you should definitely install this CodeQL VSCode extension. It enables you to just add the CodeQL database. If you look on the left-hand side of the tab, you can see CodeQL DB. there's a CPP database that's there. You can create a new query with a wizard in the UI directly. In the middle, you'll see a query that's loaded, the file, and it's just a very simple CodeQL query that looks for function calls, and then you get the syntax highlight, but also code completion. As Fredrik said before, if we have a different standard library for CPP and Go, when you change from one to the other, it's very useful to have code completion. And by using this, it's much easier to write queries if you're not used to as well. And then when you're ready to run the query, you get the results on the right-hand side, and you see a list of all the results that this query found. And if you click on any of them, the VS Code will navigate you to the result location. This extension also has some more advanced features, and one of them is, you can see it on the left-hand corner, very tiny, called AST Viewer, and this will show you an internal representation of the code base within the CodeQL language, let's say. And this allows you to, if you're looking for a particular node or pattern in the code, you can see in the AST Viewer how that code is represented within CodeQL, and then write a query for that particular node. This is extremely useful also when you're getting used to how the standard library and the code representation within CodeQL works. And the other more advanced feature that's also useful sometimes is to see performance metrics. So actually, sometimes these taint tracking or some data flow queries can take a long time to run. And you might be interested in knowing which predicates in the query take the longest time. There's actually a way to do that within the VS Code extension directly. The other essential tool for us, and this is a tool we're actually releasing today, so it's available from today. It hasn't been announced, but you can search for it in the marketplace already, is the SARIF Explorer. The SARIF Explorer is a VS Code extension that you can basically visualize any SARIF file, and this means that you can visualize any SARIF file from any static analysis tools. So nowadays, Semgrep, CodeQL, and all these static analysis tools will often output the results in the SARIF file format, and then we can load them, all of these results, into VS Code and navigate through them and go through them, classify them directly, all at the same time. And we developed this extension not because there weren't any visualizers for SARIF files before, but because the ones that existed were not particularly suited to our needs as code reviewers or as people that go through lots and lots, sometimes thousands of static analysis results. This means that we need to be able to quickly classify the results, filter results by keywords or by files or folders, but also to disable some rules. And while doing all this within VS Code and all the SARIF files at the same time, allow us much more efficiency while doing this process. And remember, we run a bunch of static analysis tools at the start of our code engagements, so we need to be kind of efficient while doing this. And if you look here, the right-hand side panel is from this VS Code extension, and you'll get exactly the same results as you got from the CodeQL VSCode extension. You'll see a list of results, but you also see above a filter by keyword box. And if you write there, for example, encrypt, you get that the result list is filtered and only shows results that include the word encrypt. This is very useful if you're looking for, let's say, I'm wondering if this particular part of the code has an issue and I can search for that word, or you can also look for particular paths or exclude paths. So suppose you have in the code base some third-party code that you don't want to consider or review the results for. You can just exclude that part and exclude all third-party results. What you can also do is disable some rules. So sometimes rules are very noisy or not really interesting for your project. So you can just disable these and ignore them while you process the other results. So here you only see one rule. It's called function call, and it's the one corresponding to this file. And finally, once you click on one of the results on the right, VS Code will also navigate you to that result location, but also on the bottom right hand corner, you'll see a new panel that if we zoom into, we can have a bit of a deeper look into it. So on the top, you have some buttons that allow you to quickly classify this as a bug, as a false positive or unknown, but also to create directly a GitHub issue. So this will open a GitHub page to create a new issue for this result location with the code snippet, and it makes the process of opening issues much quicker if you just have this. You can also add comments, and these comments will be specific to this result location, and you can see all the description and rule that is corresponding to this particular result. And finally, once you are done with with classifying all the results as bugs, false positives, and any comments, you can share this file or a file that's the extension outputs with your teammates so that they can also work on what you previously worked on and continue, let's say, from where you did not classify. These extensions that we showed are essential, and I believe if you want to write custom queries, you should definitely install all of these. Well, NeoVim if you use NeoVim, the VS Code extensions if you use VS Code extension, VS Code. But regardless, if you are writing custom queries, these are fundamental for you. If you, on the other hand, you're not that interested in writing custom queries, you can also use CodeQL nonetheless and use it inside CI, and that's what Fredrik will tell you about now.
Yeah, so before we move on to CI, I think we had some good questions. So maybe we should take a second to go through those. So the first one is actually, I mean, this is always great, right? When the audience knows where the presentation is going and asks about what's coming later in the presentation. So we're going to talk about CI, and in particular, we're going to talk about how to use your own rules in CI. So we'll get to that. The next question was on the CodeQL cpp-queries, if that is a path to a folder or if it's embedded in the releases version of CodeQL. So could you comment on that, Filipe?
Yeah, so CodeQL CPP-queries, let me see, is this mentioned regarding...
I think it's naming the query pack that you wrote.
Okay, okay, it could have been a folder here.
So maybe it was actually in my part of the presentation.
Ah, I see. Was it here?
Yeah,
okay.
that was probably it. Yeah,
okay. Yeah, so this actually is not, this is, so when you download CodeQL CLI from this bundle here, you automatically get the standard query packs together with the CodeQL CLI. And CodeQL CPP queries is one of these packs that you get when you download this CodeQL CLI from the bundle. This would be different if you just did brew install on CodeQL CLI, and that's not something we'd recommend. Instead, just download the bundle and go from there. You should get the queries directly from there. Yeah.
Yeah. Thanks. And
right.
the final question.
Okay.
Yeah.
Okay, let's read the question. If you have a CodeQL database instead of a source enlistment, will the SARIF Explorer navigate to the source in the database? That's actually a good question. And the answer is no. The way the SARIF file works, no. The way the SARIF file works is that it has a path, and the CodeQL database does indeed contain the source files, let's say, within a zip file within the CodeQL database. So the way this would have to work would be to, the SARIF file would need to have a way to say to the viewer interpreting the SARIF file that the path is within a zip file, and then this extension will need to open the zip file within the CodeQL database. This is exactly what the VSCode CodeQL extension does, but the SARIF Explorer does not work like that. It just looks at the path in your folder, let's say, but you can still, let's say, if the folder you're looking at was not the folder where you ran the query on, you can point the SARIF viewer or the SARIF Explorer to a different folder in your computer and basically set up the base folder. So this wouldn't work with the zip version within the CodeQL database. Yeah, I hope that answers the question. All right.
Okay.
These were great questions.
Okay. Let's take a look at how you would go about running CodeQL in CI. So we're going to look at how it works on GitHub. Obviously, if you're hosting the code yourself, this will be very different. I do want to say, though, because this is something that people sometimes get confused about, you are allowed to use CodeQL on third-party CI systems like Travis, for example. And you're also allowed to use CodeQL for code hosted on other services, as long as you have GitHub Advanced Security. But now we're going to look at what it looks like to set this up on GitHub, because that is what most people use to host their code. So to set up CodeQL scanning in CI, you navigate to the Security tab, and there should be a page, or rather a section called Code Scanning, which allows you to enable CodeQL analysis. And basically, there are two different ways to do this. You can either choose the default option or the advanced option. What's nice about the default option is that it will configure everything for you. So it will detect the language you're using. It will detect, or at least try to detect, how to build the database automatically. And it will run everything automatically on each pull request. Default will also detect if you add new code to the repo, which is in a different language that is supported by CodeQL. That will be sort of included in the scan automatically. And that there are also some configuration that you can do. So you can actually set up the languages that you want CodeQL to run on, and you can also select from a set of predefined query sets that you want to run. So there is some customization that you can do. But if you want to customize this workflow a bit more, then you want to run it using the advanced customization, or configuration rather. So code scanning with CodeQL runs as a GitHub action under the hood, right? And if you choose advanced, you'll basically add a new YAML configuration file to your GitHub actions, and you can just configure this in any way you want. So you can add, you can obviously decide which languages you want to scan. You can decide which query packs you want to run. You can filter query results after the scan is complete, and you can perform a number of different steps. So that is super nice if you want to be more targeted. And here you can also add your own queries or query packs, like the Trailbit C++ queries or the Trailbit Go queries that we published.
Fredrik, could you explain what the difference is between queries and packs? It seems a bit the same.
Yeah, that's a good question. So you can, in this YAML file, you can specify queries and you can specify packs. And queries are what's known as query suites in CodeQL, and packs are query packs. So a query pack is a set of queries that you can publish and download using the CodeQL CLI. A query suite is really like an abstraction on top of query packs, where you can bundle a set of query packs, for example, but you can also say that I want all the queries from these 3 query packs, but I only want those that are tagged with security and that give me high severity issues. So you can sort of use query suites to slice things in a number of different ways. And the CodeQL CLI comes with a set of query suites already defined. So like the security extended and security and quality are sort of defined by the CodeQL CLI. And the example query pack here, TrailofBits/cpp-queries, is a query pack published by TrailofBits. And here you can actually also specify, if you want to include a query with your repo, then you can actually specify that here as well. So you can run sort of local queries on your code base on each pull request, for example. So that was the question that we had before. So there's actually an example in the testing handbook of how to do that. So that's a great question. Okay, and I think what's nice here is that you get all the new results as issues on your pull request. So you can triage results in the pull request on GitHub. So here you can obviously fix the issue, or you can mark it as a false positive, or as testing code, or that it won't be fixed for some reason. So I think that is really nice.
And can anyone see these alerts, or only the maintainer?
Yeah, that's a really good question. So that's something to be mindful of. So anyone with read permissions can see code scanning results on pull requests. So obviously, if you have a public open source repo, that means anyone, right? But as long as issues are resolved before you merge the pull request, that shouldn't really be an issue. But yeah, it's something to be aware about. If you mindlessly merge pull requests without looking at the issues that CodeQL raised, then you may be merging security issues into main that people actually know about because they've seen them flagged on the pull request. So you shouldn't do that. I think what's nice with code scanning, and I think you can see that if we go back. If you look here, you can actually add protection rules. So you see that below this sort of pop up here. Something called pull request check failure, which means that if CodeQL detects an issue, then it'll block the pull request from merging. So I think that is something that is really great. There's also a code scanning section under the security tab where you can go in and look at all the issues in your repo. So these will be issues on all branches, like main, for example. And you can slice these in a number of ways. So you can say that I want to see issues on main, or I want to see issues on a particular pull request, or that contains a particular word, for example. And that is really nice. And you can use this to triage issues as well. Here, it's good to know that you need write permissions to see these code scanning summaries under the security tab. So that means that you need write permissions to the repo before you can see unresolved issues on the main branch, which I think is a good decision by GitHub. Our key takeaways for this section is that we think code scanning with CodeQL on GitHub is great. I mean, there's really no downside as long as you have the action minutes to spare. So if your code base is public and open source, or if it's covered by GitHub Advanced Security, then we think that you should enable this. Obviously, it makes sense to start out with a default configuration to get everything set up automatically. And then if you need to, you can switch to advanced later on, right? If you want to specify your own build command, or if you want to run your own custom queries. Okay, I don't know, do we have any questions?
I don't think so at this point.
Okay, cool.
So we're wrapping up. So, and where can you find support? You can email us, any of us, me, Fredrik, or Vasco. But also you can get support at the Empire Hacking Slack community. We have a dedicated Slack channel for the Testing Handbook, and you can go there and ask us any questions about any content on the Testing Handbook. You could also just go there. There's a bunch of other Slack channels there for our open source tools that we have at Trilobits. And also the Testing Handbook has a GitHub, public GitHub, where you can open issues or open pull requests, even if you want to add some comment or you saw some typos that you'd like to fix. And finally, to conclude, we have these great resources at AppSec Guide, the Testing Handbook, and we did the previous Semgrep webinar that you can go and watch if you didn't at our YouTube channel at Trilobits. And also in our blog, we have a bunch of cool blog posts about how we used CodeQL to find issues in client code bases, or also, let's say the divergent representation one is a good example where CodeQL was used in a research project after we found an issue in SQLite, high severity issue, some time ago.
Yeah, I also recommend that you check out our public reports, because they actually contain a lot of information about how we use CodeQL at Trilobits. So our most recent report format actually contains a whole section on the automated tooling that we use on our code reviews. And there we describe the tools that we used, how we used them, the configuration, the queries that we wrote, if we found anything, right? So I think that is a great way to get familiar with how we use CodeQL. So please check those out. And yeah, please use our public CodeQL queries and tell us what we find, or what you find rather. And also tell us if there are ways that you think we could improve them. Okay, I think that is everything that we had for today. If there are any questions, we'd be happy to answer them now. And yeah, apart from that, check out our resources and SARIF Explorer that we're sort of soft launching today. You'll be the first ones to try it out. Okay. If there are no questions from the audience, I would like to thank everyone for your time. It's been great. And please feel free to reach out to us. We're happy to talk about CodeQL or code review at any time. Please join the Empire Slacking Hack or just email me or Filipe. Yeah, actually, we got a question now from someone. Is it possible to scan public repos on merge PR with CI? Yes. So I think, well, depending slightly on what you mean here. So if you have a public repo on GitHub and you want to set up code scanning, so each new pull request is scanned, then that is definitely possible. So the scan won't actually happen when you merge into main. I think you can set it. Actually, I think you can probably set it up so it scans on merge to main as well, but or with another branch if you're interested in that. But I think the default is that you get a new scan whenever you update the pull request, and then you can see all the issues and sort of fix all the issues before you merge with main. But you can definitely set it up so that it scans on the merge as well. If you're interested in scanning other public repos, there is a way on GitHub. So I forget the name. Do you know what I'm talking about, Filipe? Where you can scan
repo variant analysis. Is this what?
Yes, thank you. It's multi-repo variant analysis. So I think there you can scan the top public repos, and that is great if you have a query for a security issue that you want to test out. You can run this on a large set of repositories at GitHub and see what you get, basically. So I think that is a really cool thing as well.